So hello and welcome back. In our study of probabilistic robotics, we obviously have to also study probability. So some key points that are going to become more important later are joint and conditional probability. Joint probability is stated as the probability that x equals x and y equals y, or the probability of xy. If x and y are independent, then we can say that the probability of xy is just the product of p of x times p of y. For conditional probability, that would be the probability of x given y. We could say that that's equal to the probability of x and y, which is the joint probability divided by p of y. Or solving that for the probability of x and y, that would be the probability of x and y is equal to the probability of x given y times p of y. If x and y are independent, we can then write that as the probability of x given y is just p of x. So here's an example of joint probability marginalization. So given that I have a table of probabilities here, what is the probability that x equals a? So you would find the probability that x equals a and y equals a and add that to the probability that x equals a and y equals b. So 0.6 plus 0.2 is 0.8. Or what is the probability that y equals b? So you would find the probability that x equals a and y equals b. That's 0.2 plus the probability that x equals b and y equals b. That's 0.3. For conditional probability, we use the formula, the probability of x given y. So the probability that x equals a given that y equals b. So that would be the probability that x equals a and y equals b divided by the probability that y equals b. We're assuming that these are dependent. So that would be 0.2 over 0.3 or 2/3. What is the probability that y equals a given that x equals a? So that's going to be the probability that y equals a over x equals a divided by the probability of x equals a, which is 3/4.